Animal nutrition focuses on the dietary needs of domesticated animals, primarily those in agriculture and food production. Introduction to animal nutrition. There are 7 major classes of nutrients: carbohydrates, fats, fiber, minerals, protein, vitamin, and water. The macronutrients provide structural material and energy. Some of the structural material can be used to generate energy internally, and in either case it is measured in joules or calories. Carbohydrates and proteins provide 17 kilojoules approximately of energy per gram, while fats provide 37 kilojoules per gram, though the net energy from either depends on such factors as absorption and digestive effort, which vary substantially from instance to instance. Vitamins, minerals, fiber, and water do not provide energy, but are required for other reasons. A third-class dietary material, fiber, seems also to be required, for both mechanical and biochemical reasons, though the exact reasons remain unclear. Molecules of carbohydrates and fats consist of carbon, hydrogen, and oxygen atoms. Carbohydrates range from simple monosaccharides to complex polysaccharides. Fats are triglycerides, made of assorted fatty acid monomers bound to glycerol backbone. Some fatty acids, but not all, are essential in the diet. They cannot be synthesized in the body. Protein molecules contain nitrogen atoms in addition to carbon, oxygen, and hydrogen. The fundamental components of protein are nitrogen-containing amino acids, some of which are essential in the sense that humans cannot make them internally. Some of the amino acids are convertible to glucose and can be used for energy production just as ordinary glucose. By breaking down existing protein, some glucose can be produced internally. The remaining amino acids are discarded, primarily as urea in urine. This occurs normally only during prolonged starvation. Other micronutrients include antioxidants and phytochemicals which are said to influence some body systems. Their necessity is not as well established as in the case of, for instance, vitamins. Most foods contain a mix of some or all of the nutrient classes, together with other substances such as toxins or various sorts. Some nutrients can be stored internally, while others are required more or less continuously. Poor health can be caused by a lack of required nutrients or, in extreme cases, too much of a required nutrient. For example, both salt and water will cause illness or even death in too large amounts. Carbohydrates. Carbohydrates may be classified as monosaccharides, disaccharides, or polysaccharides depending on the number of monomer units they contain. They constitute a large part of foods such as rice, noodles, bread, and other grain-based products. Monosaccharides contain 1 sugar unit, disaccharides 2, and polysaccharides 3 or more. Polysaccharides are often referred to as complex carbohydrates because they are typically long multiple-branched chains of sugar units. The difference is that complex carbohydrates take longer to digest and absorb since their sugar units must be separated from the chain before absorption. The spike in blood glucose levels after ingestion of simple sugars is thought to be related to some of the heart and vascular diseases which have become more frequent in recent times. Simple sugars form a greater part of modern diets than formerly, perhaps leading to more cardiovascular disease. The degree of causation is still not clear, however. Fat. A molecule of dietary fat typically consists of several fatty acids, bonded to a glycerol. They are typically found as triglycerides. Fats may be classified as saturated or unsaturated depending on the detailed structure of the fatty acids involved. Saturated fats have all of the carbon atoms in their fatty acid chains bonded to hydrogen atoms, whereas unsaturated fats have some of these carbon atoms double bonded, so their molecules have relatively fewer hydrogen atoms than a saturated fatty acid of the same length. Unsaturated fats may be further classified as monounsaturated or polyunsaturated. Furthermore, depending on the location of the double bond in the fatty acid chain, unsaturated fatty acids are classified as omega-3 or omega-6 fatty acids. Trans fats are a type of unsaturated fat with trans isomer bonds. These are rare in nature and in foods from natural sources. They are typically created in an industrial process called hydrogenation. Many studies have shown that unsaturated fats, particularly monounsaturated fats, are best in the human diet. Saturated fats, typically from animal sources, are next, while trans fats are to be avoided. Saturated and some trans fats are typically solid at room temperature, while unsaturated fats are typically liquids. Trans fats are very rare in nature, but have properties useful in the food processing industry, such as rancid resistance. Essential fatty acids equals. Most fatty acids are non-essential, meaning the body can produce them as needed, generally from other fatty acids and always by expending energy to do so. However, in humans at least 2 fatty acids are essential and must be included in the diet. An appropriate balance of essential fatty acids omega-3 and omega-6 fatty acids seems also important for health, though definitive experimental demonstration has been elusive. Both of these omega long-chain polyunsaturated fatty acids are substrates for a class of eicosanoids known as prostaglandins, which have roles throughout the human body. They are hormones, in some respects. The omega-3 eicosapentaenoic acid, which can be made in the human body from the omega-3 essential fatty acid alpha-linolenic acid, or taken in through marine food sources, serves as a building block for series 3 prostaglandins. The omega-6 diomega-gamma-linolenic acid serves as a building block for series 1 prostaglandins, whereas arachidonic acid serves as a building block for series 2 prostaglandins. Both DGLA and AA can be made from the omega-6 linoleic acid in the human body, or can be taken in directly through food. An appropriately balanced intake of omega-3 and omega-6 partly determines the relative production of different prostaglandins. One reason a balance between omega-3 and omega-6 is believed important for cardiovascular health. In industrialized societies, people typically consume large amounts of processed vegetable oils, which have reduced amounts of the essential fatty acids along with too much of omega-6 fatty acids relative to omega-3 fatty acids. The conversion rate of omega-6 DGLA to AA largely determines the production of the prostaglandins PGE1 and PGE2. Omega-3 EPA prevents AA from being released from membranes, thereby skewing prostaglandin balance away from pro-inflammatory PGE2 toward anti-inflammatory PGE1. Moreover, the conversion of DGLA to AA is controlled by the enzyme delta-5 desaturase, which in turn is controlled by hormones such as insulin and glucagon. The amount and type of carbohydrates consumed, along with some types of amino acid, can influence processes involving insulin, glucagon, and other hormones. Therefore the ratio of omega-3 versus omega-6 has wide effects on general health, and specific effects on immune function and inflammation, and mitosis. Good sources of essential fatty acids include most vegetables, nuts, seeds, and marine oils. Some of the best sources are fish, flaxseed oils, soybeans, pumpkin seeds, sunflower seeds, and walnuts. Fiber. Dietary fiber is a carbohydrate that is incompletely absorbed in humans and in some animals. Like all carbohydrates, when it is metabolized it can produce 4 calories of energy per gram. But in most circumstances it accounts for less than that because of its limited absorption and digestibility. Dietary fiber consists mainly of cellulose, a large carbohydrate polymer that is indigestible because humans do not have the required enzymes to disassemble it. There are 2 subcategories, soluble and insoluble fiber. Whole grains, fruits, and vegetables are good sources of dietary fiber. Fiber is important to digestive health and is thought to reduce the risk of colon cancer. For mechanical reasons it can help in alleviating both constipation and diarrhea. Fiber provides bulk to the intestinal contents, and insoluble fiber especially stimulates peristalsis, the rhythmic muscular contractions of the intestines which move digester along the digestive tract. Some soluble fibers produce a solution of high viscosity. This is essentially a gel, which slows the movement of food through the intestines. Additionally, fiber, perhaps especially that from whole grains, may help lessen insulin spikes and reduce the risk of type 2 diabetes. Protein. Proteins are the basis of many animal body structures. they also form the enzymes which control chemical reactions throughout the body. Each molecule is composed of amino acids which are characterized by inclusion of nitrogen and sometimes sulfur. The body requires amino acids to produce new proteins and to replace damaged proteins. As there is no protein or amino acid storage provision, amino acids must be present in the diet. Excess amino acids are discarded, typically in the urine. For all animals, some amino acids are essential and some are non-essential. About 20 amino acids are found in the human body, and about 10 of these are essential, and therefore must be included in the diet. A diet that contains adequate amounts of amino acids is particularly important in some situations, during early development and maturation, pregnancy, lactation, or injury. A complete protein source contains all the essential amino acids. An incomplete protein source lacks one or more of the essential amino acids. It is possible to combine two incomplete protein sources to make a complete protein source, and characteristic combinations are the basis of distinct cultural cooking traditions. Sources of dietary protein include meats, tofu and other soy products, eggs, grains, legumes, and dairy products such as milk and cheese. A few amino acids from protein can be converted into glucose and used for fuel through a process called gluconeogenesis. This is done in quantity only during starvation. The amino acids remaining after such conversion are discarded. Minerals. Dietary minerals are the chemical elements required by living organisms, other than the four elements carbon, hydrogen, nitrogen, and oxygen that are present in nearly all organic molecules. The term mineral is archaic, since the intent is to describe simply the less common elements in the diet. Some are heavier than the four just mentioned, including several metals, which often occur as ions in the body. Some dietitians recommend that these be supplied from foods in which they occur naturally, or at least as complex compounds, or sometimes even from natural inorganic sources. Some are absorbed much more readily in the ionic forms found in such sources. On the other hand, minerals are often artificially added to the diet as supplements. The most famous is likely iodine in iodized salt, which prevents goiter. Macrominerals many elements are essential in relative quantity. They are usually called bulk minerals. Some are structural, but many play a role as electrolytes. Elements with recommended dietary allowance greater than 200 mg day are, in alphabetical order, calcium, a common electrolyte, but also needed structural, chlorine is chloride ions. Very common electrolyte. See sodium, below, magnesium, required for processing ATP and related reactions, phosphorus, required component of bones. Essential for energy processing, potassium, a very common electrolyte, sodium, a very common electrolyte. Not generally found in dietary supplements, despite being needed in large quantities, because the ion is very common in food, typically as sodium chloride, or common salt, sulfur for 3 essential amino acids and therefore many proteins. Trace minerals many elements are required in trace amounts, usually because they play a catalytic role in enzymes. Some trace mineral elements are Da,